All right, so here we're given a data set about top-selling soft drink brands. We have, apparently, I don't know how to count. Proofreading, folks. It's good. It's good for the soul. All right. Where did my gin go? There we go. All right. So we got Coke, Pepsi, Diet Coke, Sprite, Dr. Pepper, Mountain Dew, Diet Pepsi, 7-Up, caffeine-free Diet Coke, and caffeine-free Diet Pepsi, with millions of cases sold in this column. So now what I'm going to do is I want to find the mean of the number of cases sold. So, of course, this is not a population. This is going to be a sample because these are samples of soda brands. There's so many more. So X bar equals 676.6 million cases sold. Okay, so now we want to find the deviations between the cases sold and the mean. So I'm going to make a chart here. All right, so I went ahead and started, I made a chart with the brands and the X minus X mean, and I got sick of writing, so I stopped writing this part. But here's the X minus X bar, or the deviations. Horrible timing, cell phone. Horrible timing. Bad cell phone. So anyway, then I squared them all, and these are pretty large numbers. But the problem only asks us to find the deviations, which were right here. All right, so the range, the variance, and the standard deviation I already found. The variance is going to be the sum of these guys divided by n minus 1. So first of all, the range, highest value is 1929, lowest value is 97. So range is 1929 million minus 97 million, and that equals, oh great calculator, 1832. The variance is the sum of these bad boys divided by n minus 1. So I'm going to pause and I'm going to find that. Alright, so I added all these guys up. Okay? That total is big 2, 9, 5, 8, 5, 6, 6.4, and I have n minus 1 values, or 10 minus 1. So that's that number divided by 9, which is 3, 2, 8, 7 to 9.6. And that's your variance. The standard deviation, or S, because this is a sample, is the square root of this obnoxious number. We didn't actually need the range. So 3, 2, 8, 7 to 9.6 equals, second square root, second answer. No, I said answer. And that comes up to 573.35 million cases is the standard deviation of this data set. Okay? So, again, that gets really nasty when you do it by hand. It was a lot of work. I had to pause the video a whole bunch to do a lot of arithmetic that you can really get bogged down in. So I definitely want you to watch the video on how to do that in Excel. It's like 3 button clicks and boom, you have it. It's awesome. Empirical rule. So when we have data that's approximately normal, as in the bell-shaped, why does that keep doing that to me? So if we're going to go like the bell shape, sorry, where it's kind of in the middle. Okay, the following things hold. About 68% of the data values are located within the distance of one standard deviation for the of the data values are located within a distance of one standard deviation from the mean. About 90%, 95% of the data values are located within two standard deviations of the mean. And about 99.7% of the data values are located within three standard deviations of the mean. So what does that actually mean? Well, here is a bell-shaped distribution. This is the mean. Okay, this dotted line is the mean. This is minus one standard deviation, plus one standard deviation, and 60% of the data is going to lie within this yellow region. The 95% of all your data is going to go between these two green regions and this yellow region. And 99.7% of the data is going to be between -3 and +3. There is more data that could lie out in these areas, but those are outliers. Those are the really strange cases. There's a lot of things that we can study that are considered normal, such as human body temperatures, human heights, there's a lot of other things that fall within that quote-unquote normal range. So if we were thinking about human beings and their height, if we were able to measure the height of every single human being, okay, 99.7% of them would be in between these data values. There is more specific stuff on the empirical rule in your textbook, so make sure you look at that stuff, all right? We're going to talk about quartiles and percentiles. The quartiles of a data set divide the data set into quarters. The first quartile, Q1, is the 25th percentile, which means 25% of the data is below that mark. The second quartile, Q2, is the 50th percentile, but in this case, we just used a median. And the third quartile, Q3, is the 75th percentile. We calculate our quartiles with this formula. All right, so we want to find Q1. We have this data set. It's 12 dance students auditioning for admission to a dance school. So the first thing we're going to do is make this work for me. Yay, there we go. So I equals 25 over 100 times 12. So 1/4 times 12 is equal to 3. That means the quartile is between the third and fourth position. The second quartile is the median, which is 68 plus 75 over 2, and that equals 71.5. And the third quartile is I equals 75 over 100 times 12 equals 9. So that is between the 9th and 10th positions, or the mean of the 9th and 10th positions. Also, a note, this data is ordered for me. If you have an unordered data set, you must order it. Okay, you must put it from smallest to greatest, because that's going to help us when we do our 5-number summary. So our first quartile was between 3 and 4. So Q1 is the average of 62 and 56, which is 59. So our first quartile is 59. Our median was 71.5. Oh, stop it. 71.5. And our third quartile, again, was the average of the 9th and 10th position. So 81 plus 85 divided by 2 is 83. So Q3 is 83. All right. Keep those numbers in mind because we're going to need them. So, interquartile range is our robust measure of variability, and it'll also help us find the outliers in this data set if there are any. So our interquartile range is Q3 minus Q1, which is 83 minus 59, which equals 24. So we found the IRQ. It was 24. So 5-number summary is the minimum, quartile 1, the median, quartile 3, and the maximum. So let's find the 5-number summary. Our minimum is the smallest data point, which is 30. Our quartile 1 was 59. Our median was 71.5. Quartile 3 was, I believe, 83, but we're going to check anyway. It was 83. And our maximum is 94. This gives us a nice description of how the data is laid out. And we're going to do it graphically as well. You're going to need this 5-number summary for the box plot that we're going to draw in a minute. So here's a box and whisker plot. This is a graphical way of displaying the 5-number summary. Here's our box, and this actually represents our interquartile range. This line indicates the median. This is our quartile 1. This is our quartile 3. These are what we call whiskers. Here is our min and our max. They're also known as the lower and upper fences. If there are outliers in the data set, which I'm going to do a second video on building a box and whisker plot with outliers, those would be our values that we find for the lower and upper fence, which I'm going to show you how to do. Our upper and lower hinges are our quartiles, and here's a number line with a scale that represents all possible data points. Steps for the box and whisker plot. First, you need to find your 5-number summary. We have done that. The next thing, why are you not giving me my pen? Do you not like me anymore? I don't think my computer likes me anymore. So, we already found the 5-number summary. We have that done. Now we need to determine the upper and lower fences. So the lower fence is our first quartile, which if we go back to our 5-number summary, which was 59, minus 1.5 times the interquartile range of 24. And our upper fence, which was our third quartile, which was 83, plus 1.5 times 24. Plug those into the calculator. That is 23. And our upper fence is 119. We have no data values that lie outside the upper fence and the lower fence, so we have nothing called an outlier. Outliers are data that doesn't really fit with what we're doing. So we don't have any outliers. So now let's cut on over to MS Paint. Yes, I'll keep the ink annotations. And we are going to draw an appropriate scale for my data values. I'm going to pause to get that done for you. Alright, so I've drawn an appropriate scale for our box and whisker plot. The next step that I want to do is to draw vertical lines for Q1, the median, and Q3. There we go. So our first quartile was at 59. And I'm so cheating and using a bar tool. So at 59. Will you be straight? Our median was at 71.5. And, oh my God, I hate this thing. And our last quartile was at 83. Stay put. 83. Okay. Now, if we have outliers, we will put lines at our upper and lower fences, but we do not. So we're going to put our lines at our minimum and maximum values. So we have a minimum at 30, and we have a maximum at 94. Now we need to connect our quartiles and our median to make our box. You want to make that as straight as possible. Draw your whiskers to your fences. Give the graph a title. And you're done. Check out the next video to see how to do it with outliers.